Hello grade 9 students. In this video we are going to solve typical exercises related to chapter 3. Get ready, prepare your chemistry guide, your chemistry notebook and a pen. Let's solve problem 18, page 47 in the support guide. 1,2-dichloroethene of molecular formula C₂HCl is an efficient spot remover, but it is toxic even in small quantities, so it should not be inhaled. A molecule of 1,2-dichloroethene consists of three elements, carbon, hydrogen, and chlorine, which are represented respectively by the atomic symbols C612, H11, and Cl1735. Part 1. Write the electron configuration of each of these three atoms. The atomic number Z is equal to the number of protons. In a neutral atom, the number of electrons is equal to the number of protons, so the electron configuration of carbon is K2L4, that of hydrogen is K1, and that of chlorine is K2L8M7. Fill in the following table, knowing that the relative charge of one proton is 1 plus and the electron configuration of chlorine is K2L8M7. Let's find the charge of the nucleus of chlorine. The charge of the nucleus is equal to the number of protons multiplied by the charge of one proton plus the number of neutrons multiplied by the charge of one neutron. But the number of protons is equal to the atomic number Z, and the charge of one neutron is 0, so the nuclear charge of chlorine is 17 multiplied by 1 plus 0, which is equal to 17 plus. To which column does chlorine belong? Chlorine has 7 valence electrons, so it belongs to column 17. To which row does chlorine belong? Chlorine has 3 occupied energy levels K, L, and M, so it belongs to row 3. What is the valence of chlorine? Chlorine has 7 valence electrons, so it needs 1 electron to be stable and achieve octet rule, so the valency is 1. To which family does chlorine belong? Chlorine belongs to column 17 in the periodic table, which is group 7, named halogens. Part 3. Identify the type of bond between the two carbon atoms in the adjacent molecule. The two carbon atoms here are sharing 2 pairs of electrons, so the bond is double covalent bond. The molecules C₂H2Cl2 that enter the organism are not eliminated as they are, but they are transformed in the liver into toxic products of formula C₂H2O2Cl2. In part 4, give the Lewis dot symbol of an oxygen atom, knowing that it has 6 valence electrons. We put the symbol of oxygen atom, which is O, and 6 dots around it on the 4 sides, as shown here. Part 5. Specify the valence of an oxygen atom. Oxygen atom needs 2 electrons to be stable and achieve its octet, so the valence of oxygen is 2. Or, oxygen atom has 2 single unpaired electrons in the Lewis dot symbol, so the valence of oxygen is 2. Part 6. Write a Lewis dot structure of the molecule C₂H2O2Cl2 where the bond between the two carbon atoms is a single covalent bond. Given the Lewis dot symbol of carbon, hydrogen, oxygen, and chlorine. First of all, put the Lewis dot symbol of two carbon atoms and join the unpaired electrons opposite to each other by a single covalent bond. And then put the other atoms and join the other unpaired electrons, as shown here. This is the Lewis dot structure of C₂H2O2Cl2. Knowing that a molecule could have more than one Lewis dot structure, we can rearrange the atoms in order to have another Lewis dot structure where the unpaired electrons are joined with each other. This is another Lewis dot structure for C₂H2O2Cl2 molecule. Let's solve now problem 24, page 51. Magnesium chloride MgCl2 is a salt that has various uses. It is safe for the environment, that's why it is used in agriculture. Magnesium chloride is a powerful hydrotherapy that has a strong excretory effect. It is used in case of cellular toxication to kick the toxins out from the tissues. Given the following extract of the periodic table, Part 1. Based on the extract of the periodic table, answer the following questions. Part A. Determine the atomic number of the element magnesium. Magnesium belongs to the third row of the periodic table, so it has three occupied energy levels, K, L, and M. Magnesium belongs to the second column of the periodic table, so it has two valence electrons. So the electron configuration of magnesium is K2L8M2. The number of electrons in magnesium is 2 plus 8 plus 2 equals 12. In a neutral atom, the number of protons is equal to the number of electrons, then the atomic number of magnesium is 12. Part B. Determine the number of valence electrons in a chlorine atom. Chlorine belongs to column 17 in the periodic table, so it has 7 valence electrons. Part C. Write the Lewis electron dot symbol of the elements nitrogen and hydrogen. Nitrogen belongs to column 15 in the periodic table, so it has 5 valence electrons. This is the Lewis dot symbol of nitrogen. Hydrogen belongs to column 1 in the periodic table, so it has 1 valence electron. This is the Lewis dot symbol of hydrogen atom. Part 2. Write the Lewis electron dot structure of ammonia and H3 and indicate the type of bonds in this compound. This is the Lewis dot symbol of nitrogen atom, and this is the Lewis dot symbol of 3 hydrogen atoms. Each hydrogen atom shares with nitrogen one pair of electrons, forming 3 single covalent bonds. Part 3. Explain the formation of magnesium chloride MgCl2. Mg belongs to column 2 in the periodic table. It is to the left of the stair-step line, so it is a metal. However, chlorine belongs to column 17 in the periodic table. It is to the right of the stair-step line, so it is a nonmetal. For Mg and Cl to achieve their octet, transfer of electrons will occur from the metal to the nonmetal. So Mg loses 2 electrons and transforms into a cation Mg2+. However, each chlorine gains 1 electron and transforms into an anion Cl-. The oppositely charged ions are attracted by an electrostatic force called ionic bond. Let's solve exercise 23, page 50 in the support guide. Sulfur is used in gunpowder industry, in rubber, and in colorants. One of its products is sulfur dichloride, compound 1, that is shown by the adjacent molecular model, where the yellow ball represents sulfur atom, the green ball represents a chlorine atom, and each two small balls represents a non-bonding pair of electrons. In part 1, we want to write the molecular formula of sulfur dichloride. Referring to this molecular model, sulfur dichloride is made up of one sulfur atom and two chlorine atoms, so the molecular formula is SCl2. In part 2, let's fill in the following table. Chlorine atom and sulfur atom has 3 occupied energy levels each, and the chlorine atom belongs to group 7. Let's find the number of valence electrons in a chlorine atom. Referring to the molecular model, the bonding pair represents 1 electron for a chlorine atom and 1 electron for sulfur. So chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons. The valence is the number of electrons needed to satisfy octet rule. The valence of chlorine is 1. The period is identified by the number of energy levels. Chlorine has 3 occupied energy levels, so it belongs to period 3. Similarly, sulfur atom has 6 valence electrons. 1, 2, 3, 4, 5, 6. The valence is the number of electrons needed to satisfy octet rule, so the valence of sulfur is 2. Sulfur has 6 valence electrons, so it belongs to group 6. The period is identified by the number of occupied energy levels, so sulfur belongs to period 3. In part 3a, write the electron configuration of sulfur. Sulfur has 3 occupied energy levels K, L, and M, and it has 6 valence electrons. K is saturated with 2 electrons, L is saturated with 8 electrons, and the 6 valence electrons are found on M. So the electron configuration is K2L8M6. In part 3b, give the Lewis dot symbol of sulfur and dichlorine and the Lewis dot structure of sulfur dichloride. The Lewis dot symbol of sulfur is S, surrounded by 6 dots. Each dot represents 1 valence electron. Chlorine has 7 valence electrons, so this is the Lewis dot symbol of chlorine. To write the Lewis dot structure of sulfur dichloride, put 1 sulfur atom and 2 chlorine atoms beside it, and then join the unpaired electrons with each other. In part 4, explain how sulfur has achieved its octet in compound 1 and indicate the type of the involved bond. To be stable and verify its octet, sulfur shares 1 pair of electrons with each of the 2 chlorine atoms, forming 2 single covalent bonds. Another compound of sulfur is magnesium sulfide, compound 2, that is formed between magnesium and sulfide ions. Magnesium atom loses 2 electrons to have a stable electron configuration, forming magnesium ion. Part 1. Translate the given into an equation. Magnesium atom loses 2 electrons to form magnesium ion. So the equation of formation of magnesium ion is Mg gives Mg2 plus 2 electrons. In part 2, justify by calculation that magnesium ion has a charge equal to 2 plus. Given that the relative charge of 1 proton is 1 plus, the relative charge of 1 electron is 1 minus, and the relative charge of 1 neutron is 0. The atomic number is equal to the number of protons, which is equal to 12. In a neutral atom, the number of electrons is equal to the number of protons equals 12. But magnesium loses 2 electrons to become magnesium ion. So the number of electrons in magnesium ion is 12 minus 2 equals 10. The charge of magnesium ion is equal to the charge of the protons plus the charge of the neutrons plus the charge of the electrons, equal to the number of the protons times the charge of 1 proton plus the number of neutrons times the charge of 1 neutron plus the number of electrons times the charge of 1 electron, equals 12 multiplied by 1 plus 12 multiplied by 0 plus 10 multiplied by 1 minus, which is equal to 2 plus. The figure below shows magnesium sulfide. In part 3a, identify magnesium atom in this figure. Magnesium atom loses 2 electrons to become magnesium ion, so the atom that loses 2 electrons is magnesium atom, and the atom that gains the electrons is sulfur atom. In part 3b, classify these atoms into metals and nonmetals. Magnesium is a metal since it has the tendency to lose electrons. However, sulfur is a nonmetal since it has the tendency to gain electrons. In part 3c, explain how sulfur has achieved its octet and indicate the type of bond involved. To be stable and verify their octet, magnesium loses 2 electrons to become magnesium ion. However, sulfur gains 2 electrons to become sulfide ion. The oppositely charged ions attract each other by an electrostatic force called ionic bond. Thanks for listening.